There is a quiet movement happening at estate sales across America. While most people pick through old dishes and dusty furniture, a specific kind of buyer walks straight past everything and heads for the kitchen. They are looking for one thing: a refrigerator built before 1990, preferably harvest gold, avocado green, or that strange copper tone brown that defined a decade. These buyers are not nostalgic. Most of them are electricians, HVAC technicians, and appliance repair shop owners. People who actually understand how these machines work. And they are paying cash, sometimes $150, for an appliance that everyone else considers garbage. Meanwhile, in suburban garages across the country, brand new stainless steel refrigerators sit dead. $2,000, $3,000, bought 4 or 5 years ago. Already finished. This is not bad luck. This is the result of 5 specific engineering decisions made by American manufacturers over the last 30 years. Reason number 1, the over-engineered coolant. Before 1994, almost every refrigerator in the United States was filled with a refrigerant called R12. The brand name was Freon. The Environmental Protection Agency banned it as part of the Montreal Protocol because it was destroying the ozone layer. From an environmental standpoint, that ban was correct. But here is what nobody tells you. The vintage refrigerators built around R12 were also built with massive tolerances, heavy-duty compressors, thick condenser tubing, industrial-grade components designed for an era when manufacturers did not care about shaving a few cents per unit. Modern refrigerators use R600A or isobutane. The refrigerant itself is fine. The problem is what manufacturers paired it with. To meet strict energy mandates, they shrank the compressors down to razor-thin tolerances. These smaller compressors run much longer duty cycles, generating sustained heat that degrades the internal oil and wears the system out in a fraction of the time. That avocado green refrigerator in your grandmother's basement is still running because it was over-engineered from the start. Heavy-duty everything. It did not care about a little extra heat or a little wasted electricity. Reason number 2. The dumb compressor advantage. Walk into any appliance store today, and the salesperson will brag about the technology inside the modern refrigerator: variable speed, linear compressors, Wi-Fi diagnostics, touchscreens that show you the weather. Every single one of those features is a failure point. Modern refrigerators are controlled by fragile computer motherboards. A single power surge during a summer thunderstorm can fry the entire board instantly. A brownout can do the same thing slowly over weeks. When that board dies, the refrigerator is essentially a metal box, and here is the part that should make you angry. Manufacturers frequently discontinue these proprietary control boards after 5 to 7 years. The fridge is mechanically fine, but the part does not exist anymore. The entire appliance is dead because of a circuit board the size of a paperback book. The vintage refrigerator at the estate sale has none of these problems. It uses a simple, single-speed compressor. Engineers call it a bang-bang system. The compressor is either 100% on or 100% off. The thermostat is a physical dial connected to a metal bulb filled with gas. That is the entire control system. There is nothing to fry. A 1978 General Electric refrigerator has the same number of motherboards as a hammer. Reason number 3, the copper to aluminum swap. Pull a vintage refrigerator away from the wall and look at the back. You will see thick, heavy-duty condenser coils made of solid copper, industrial-grade tubing designed to last for 50 years. Now look at the back of a modern refrigerator. The tubing is paper-thin aluminum. Copper costs roughly 4 times more per pound than aluminum, so manufacturers save somewhere between $15 and $40 per refrigerator at the factory. Here's the problem. Engineers call it formicary corrosion. Moisture in the air reacts with volatiles inside the cabinet insulation and creates microscopic pinhole leaks at the joints. You cannot see them, you cannot hear them, but every day a little more refrigerant escapes from the sealed system. By year 3, the refrigerator runs noticeably longer to maintain temperature. By year 5, the freezer cannot keep ice cream frozen. By year 6, the system is empty and the unit dies. The refrigerator is engineered to bleed out at exactly the point when the warranty expires. Reason number 4, The efficiency illusion. The salesperson points at the yellow Energy Star label and explains that this brand new refrigerator uses $80 to $100 less in electricity per year than the old one in your basement. Over 10 years, they will tell you, that is $1,000 in savings. The math sounds incredible. The math is also dishonest. You buy a new refrigerator for $2,000. You save $100 a year on electricity. After 5 years, you have saved $500 in power costs. And then your refrigerator dies because the aluminum coils leaked and the control board fried. $2,000 divided by 5 years equals $400 per year in depreciation alone. You could have bought a tank-built vintage Whirlpool at an estate sale for $150. Even with the higher electric bill, the vintage fridge saves you thousands across a decade. The Energy Star sticker measures one variable in isolation while ignoring the cost of the appliance itself. Reason number 5, survivorship bias and the bathtub curve. In engineering reliability theory, there is a concept called the bathtub curve. Plot the failure rate of any manufactured product over time, and it forms the shape of a bathtub. Failures are high at the very beginning because of factory defects. Then the failure rate drops almost zero for most of the product's useful life. At the very end, it climbs back up as materials physically wear out. Many modern refrigerators fail in 5 to 8 years because of unrepairable electronic components. They never reach the flat, middle section of the curve. Now think about what it means for a refrigerator to be sitting at an estate sale today. That unit was built in the 1970s or the 1980s. It has been plugged in for 40 or 50 years. It has survived blackouts, lightning strikes, summer heat waves, basement floods, and door slams from generations of children. Any manufacturing defects were sorted out during the Carter administration. The fact that this refrigerator is still making ice in 2026 is mathematical proof that it is in the flat, reliable section of the bathtub curve. It has proven, through 4 decades of continuous operation, that it is essentially unkillable. The American appliance industry made a deliberate choice. Sometime around 1990, manufacturers stopped competing on quality and started competing on price and features. They shrank the compressors. They swapped copper for aluminum. They added motherboards and Wi-Fi chips. And they convinced consumers that newer was automatically better. The estate sale buyers are not nostalgic. They are the people who pulled apart enough modern appliances to see what was inside them. What they saw was not an upgrade. It was a downgrade, dressed up with a touchscreen. The refrigerator your grandmother bought in 1978 was an investment. The refrigerator you bought in 2024 is a subscription. If this kind of forensic look at modern manufacturing is the content you want more of, subscribe. We tear apart a different industry every week, from recreational vehicles to power tools to construction equipment. The autopsies are just getting started, because the same engineering shortcuts hiding inside your refrigerator are hiding inside almost everything else you own. And once you start looking, you cannot stop seeing it.